So now, I thought we would look at this circuit here. I have an NPN bipolar junction transistor, basically wired as an adjustable current source. We have the 10K Trimpot that ultimately sets the base current right there. You can see as the base current rises, it puts more voltage across the 220 ohm resistor. It allows more current to flow collector to emitter, and thus through the LED right there. Of course, the LED drops a couple volts, so we can never build up more than about 3 volts from collector to emitter right there. Something to keep in mind. Now, we have a 10K resistor between the Trimpot and the resistor there. So often I don't need to use a resistor there, but in this case we do, because if I go all the way to the positive supply with the Trimpot right there, and I don't have resistance there, it doesn't necessarily have to be 10K, but you definitely need resistance there to get the voltage mostly to the base, but not overpower the collector. So right when I made the connection, the red LED briefly flashed, but right now it's easier for current to flow from the positive supply through the jumper, base to emitter, and resistor than current to flow through the LED. So unfortunately, the LED is being bypassed right there. If I turn this lower, you know, a little bit lower right there, now we got resistance over there. Current's not flowing quite as easily, base to emitter, thanks to this resistance. So it is able to get the LED to turn on fully, but we can't go all the way to the positive supply. And there we go. I think we had kind of a loose connection or something. We need this 10K resistor to help transfer the voltage, but not to overpower, have the current overpower what the LED can provide. So now let's look at this circuit more closely. We got the multimeter here. First we're going to measure voltage. We don't have to move the red probe for anything other than high current with this particular meter right there. It's auto ranging, does pretty much all the work for you. If you got to set numbers for it, make sure to set it to a number voltage higher than what you're going to measure. And so we're going to take the black probe, plug it into the negative supply, and the red probe here, I need to grab the jumper with the alligator clip, crimp to it, and gonna clip that. And now we're interested in the base voltage of the transistor, which is also the voltage that the Trimpot is sending over. So 3.5. So this is higher than what we can work with because we only have about 3 volts to work with here, because the red LED is gonna drop a couple volts. So the voltage I'm interested in, since this is a 220 ohm resistor, we want about 2.2 volts across the resistor. So I can't go 2.2 volts here because we're measuring the base. I need to get more to about 2.8 volts approximately right there, because the base to emitter drops approximately 0.6 volts. So we will look at that. I'll move this down to where the resistor is, and there you can see just shy of 2.2 volts. So we can now adjust this a little bit more, go up a little bit until we get closer to 2.2. And there we go. So main takeaway is my goal is to try to get 10 milliamps of current through that LED. I do so by getting 10 milliamps of current going through the 220 ohm resistor, which is what you will have when you have 10 volts across it. So I'm going to leave that set to measure voltage while I change things, because it's safer to accidentally measure a voltage than a current. And the current we're going to measure, we have to bridge the gap here. So I'm going to the collector, not to where that jumper is. So I'll put it next to the jumper. Make sure I don't accidentally go there. And now I will set this to measure current. The meter is not actually completing the circuit anywhere, so there will be no current. Now I go down to where the cathode of the LED is, and there you can see we shot for somehow I made a better connection when I bumped the plug. We shot for 10 milliamps of current, and I didn't set this up before. I just knew we would get about 10 milliamps of current. It's not precise, 100% precise or anything, but we basically got 10 milliamps of current right there. And so that's the way it works. You set the voltage across the 220 ohm resistor right there, You do that by changing the voltage of the Trimpot. Whatever voltage you set, it'll be 0.6 volts lower at that resistor right there. Now the collector won't determine the current at all. It will pass current as needed to meet that current that you set there, even if you go through a load. But the load does take a couple volts, so since we're using 5 volts at the supply right there, we only have about a 3 volts left after the red LED drops a couple volts. So you need about 2 volts power of the LED. You got about 3 left over there. Something to keep in mind. But in any case, I think this is an instructive circuit if you're trying to build something similar. And so there it is. And also, get the meter off of measuring current right away. Some meters have a power button. Set it to voltage before you turn it off is my recommendation. This one we have an off setting, so we don't have to worry about that. But in any case, that's it. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.